So let's do problem 45 on page 105, and this is in chapter 4. And here's the book. Zoom in a little bit here. And it says, a student is riding on a flat car of a train traveling along a straight horizontal track at a constant speed of 10 meters per second. The student throws a ball into the air along a path which he judges to make an initial angle of 60 degrees with the horizontal. And notice they don't tell you whether it's 60 degrees forward or backwards, and to be in line with the track. The student's professor, who is standing on the ground nearby, observes the ball to rise vertically, straight up. How high does she see the ball rise? Okay. So, this is a relative. So here I've drawn it. Here's the velocity of the ball. It's going straight up. That's compared to the ground. Compared to our ground. Oh, I'm sorry. Let me zoom out. Zoom out a little more. So you can see that the ball compared to the ground is going straight up. But the train is moving this way, and the person threw it at a perceived angle of 60 degrees from the horizontal, and the train's moving 10 meters per second to the right. So, well, to figure out how high the ball goes, we need to know what the initial velocity was in the y direction. So, really, that's what this is. The velocity of the ball as it leaves the hand of the thrower is going to be straight up, and we need to know what that is. So let's start with this, all relative velocity. The velocity of the ball is equal to the velocity of the ball compared to the train plus the velocity of the train. So I have to add these two vectors together to get this. So here's my answer. Let's draw it as a picture. Let me draw it as a vector diagram. Here's the velocity of the ball. So I have to add these two to get it. Now, it doesn't matter which order I add this. Let's add the one I know. I know this, right, is 10 meters per second to the right, the way I drew it. So this is the velocity of the train equals 10 meters per second to the right, which means that to get the velocity of the ball going straight up, the ball compared to the train has to be thrown like this. That makes sense? Yeah. See, the train's going this way, so for the ball to go straight up, the thrower has to cancel out that horizontal velocity plus give it some vertical velocity.
Even though when you add vectors, if you add them to the head?
No, yeah, because which two vectors? This is the velocity of the ball compared to the train right here. So these are the two I'm adding. Now remember, vector A plus B equals B plus A, in that it doesn't matter what order I add vectors, I get the same answer. So I'm really adding the velocity of the train plus the velocity of the ball compared to the train is equal to the velocity of the ball. So this is vector addition. But I know that this angle is given to be 60 degrees. And I know that this is 10, so I need to know what this is. But if I know one of the legs of a right triangle, I can say that tangent of 60 degrees is equal to the opposite, which is the velocity of the ball, divided by the opposite over the adjacent, 10 meters per second, velocity of the train. So now I can figure out the velocity of the ball is equal to 10 meters per second times the tangent of 60 degrees. So the velocity of the ball equals, oh, I don't have my calculator up here. Oh, I do. And this is why people always watch my videos at high speed. Times the tangent of 60 degrees, right? I am in degrees, yes. So that gives me 17.3. And now I want to know how high the ball is going to go. Well, I know its initial velocity, and I know its final velocity at the maximum height is 0. I don't know the time, but I don't need it. So I'm going to use the fourth kinematic equation. Vy squared equals v naught y squared plus 2a delta y. This is 0, so delta y will be equal to negative v naught y squared over 2a negative 17.3 meters per second. Square that, divide it by 2 divided by negative 9.8 meters per second squared, right? Because that's the acceleration. And so the height that it will go to is, well, I'm going to take the answer I got and square it. Answer squared. 300? That's interesting. Divided by 2. And then divided by 9.8. I get 15.3 meters. Is that the answer you get in the back? I guess, oh, that's right. You guys, hold on a second. I can find it. This is chapter 4, number 45. Yeah, 15.3 meters. Yay, clapping. Okay, so this part, I like this problem. This is just kind of a review of kinematics, right?
Yeah.
But this is the new stuff right here. But the key idea is this, that this is a vector equation. And if you can draw the picture, you'll be able to draw the triangle. And once you have the triangle, you can figure it out. Now, if this thing isn't a right triangle, see, the fact that this turned out to be a right triangle allows me to just use the trig functions. If it's not a right triangle, you can still solve it by, it's a little bit more of a pain, but you can still, by using unit vectors and that sort of thing. Oh. Any questions? Does it make sense?
Yeah, I drew the picture wrong at first.
Yeah.
Because I didn't know how you're supposed to know where the 60-degree angle was.
Right. Well, almost everybody. Okay, first time I ever did this problem, I drew this, the velocity of the ball compared to the train.
Well, that's what I did. And so all my numbers were wrong.
Right. But then, what happens when you try to do this? It doesn't work. Because then you go, okay, the velocity of the ball compared to the train plus the velocity of the train, that would be that. This is not straight up.
Yeah.
And then I realized, oh, wait. Yeah, it's got to be the other way in order for it to be straight up. So the picture, drawing the picture and making it fit what's given will let you figure it out. Being able to visualize problems is very important. It's the only way I can do it. Okay. That is all.